Hi everybody, so today I'm going to be talking about mole house. Now mole house is one of those chemistry concepts that seems really difficult at first, but once you get enough practice in it, it becomes a lot easier. So you guys might be asking, what is mole house? Well, mole house is just a way that we organize conversion factors, and we do that by drawing a diagram. Now, in future chapters, the mole house will be a lot bigger than this, but for now we're just focusing on the four main rooms. In the first room we have mass, then moles, then numbers of particles, and number of parts in particles. And the three doorways represent how we convert to each one. So molar mass you can find on the periodic table, and Avogadro's number is 6.02 times 10 to the 23rd power. And then here we have chemical formula. So we'll be referencing this mole house diagram throughout our practice problems. And also just a reminder that molar mass is always equal to 1 mole, and same goes for Avogadro's number. So just be aware of that when we're going through the practice problems. So here's our first problem. So how many molecules of carbon dioxide are in 2.5 moles of carbon dioxide? So what I did was I circled what we're trying to find, which is molecules of CO2, and what information we have so far, which is 2.5 moles. So we start by putting 2.5 moles at the beginning. And if you reference the mole house, we're trying to convert from moles to numbers of particles. So we use Avogadro's number, and we put moles on the bottom because we have to cancel it out. And if you put it in your calculator, it's 2.5 times 6.02 times 10 to the 23rd, and you'll get 1.5 times 10 to the 24 molecules of CO2. And here's our second practice problem. How many atoms of hydrogen are in 3.5 moles of ammonia? Now, same thing here, I circled what we're trying to find and what information we have. So I put 3.5 moles, and then I put 1 mole, so we cancel it out. And for this one, we're going to do 2 conversion factors. So I put Avogadro's number, and here it gets a little different because now, since we're looking for how many atoms, we have to find the chemical formula. And we do that by writing out the balanced equation. And since we're trying to find atoms of hydrogen, we put 3 atoms of hydrogen up here, and then we put 1 NH3. And if you put this in your calculator, it's 3.5 mole times 6.02 times 10 to the 23rd times 3. And then you'll get 6.32 times 10 to the 24 atoms of H2 in NH3. Now here's our last practice problem. So how many atoms of H2 are in 8.5 grams of NH3? So we put 8.5 grams first, and here's the molar mass, which we found on the periodic table. And since we're trying to convert to moles, it's on the top this time. And then we do Avogadro's number. And then we do the same thing that we did in the previous problem, is we write down the balanced equation. And since we're trying to find atoms of hydrogen, we put 3H and then 1 NH3. And once you put that in your calculator, it's 8.5 divided by 17.04 times 6.02 times 10 to the 23 times 3. And once you do that, you'll get 9.01 times 10 to the 23 atoms of H2. Well, that's all the practice problems. Thank you guys for listening, and I hope that helped you with mole house.